Okay, so today we're going to talk about polar coordinates, and a couple of key points that we need to talk about are the pole. And so the pole is basically it's the fixed point, right? It's the fixed point. In fact, I'd rather underline that. It's the fixed point, and that fixed point is right there. That's where we pivot to create our angle. And then the other thing that we need to have or talk about is the polar axis. And the polar axis is this guy right here. And it's always fixed. It's like the x-axis. It's the start of the angle, whether we rotate counterclockwise or clockwise. And then the angle that's created, is done this way. And then the terminal side that it's talking about is this guy right here. And then you can see that the radius is this piece right here. So that's the radius of our angle that's being created, or if it turns into a full circle, that's how that's going to work. Now, one of the things that I want to do is talk about how to label these points in polar coordinates. And when we label in polar coordinates, it's going to be the radius length and then the angle. That's something that's important that you guys are going to have to know and understand. So I want to make sure that you guys have that and understand it. So in this first example, here it's telling us that the radius is 2, and we can see that the angle here is pi over 4. And so when we label the point P, that's going to be 2 comma pi over 4. Okay. In this next example, we have 2 points. We have a point P and a point Q. So the point P has an angle of 2 pi over 3, and the radius, it looks like, is 1, 2, 3. So this is going to be 3 comma 2 pi over 3. Now, with that, just to reinforce what's going on, I'll do it in blue first. When I did that first one and I rotate, we can see that I'm pointed in the direction that the angle terminated at, right? So I'm pointed in that direction. Actually, that's not a very good point. I can see that I'm going or facing this way. So since I'm facing where it terminated, I'm gonna like walk forward 3 steps to get to where I'm going. So that's a positive. Now, when I'm doing to get to point Q, I still have that same angle, but now I'm gonna walk the other way. And when I walk the other way, it's like walking backwards. And so this point is going to be negative 3, 2 pi over 3. Okay? Let me just show that to you guys real quick, because I want you guys to be able to understand that clearly. So if I have some angle and it goes this way, see how it terminates and I create an angle. This point right here is going to be whatever my radius is and the angle. Now, if I were to go the other way with that and say it was the same length, this point here is called P prime. And it would be negative r theta, because instead of going forward, I'm now going backwards from where the angle is. Does that make sense? Okay, cool. Okay, so now let's label some points. These are 4 different graphs that are correlated to the point 2 pi over 4. And we can see this is the first example. That is that. Then there's 2, 3, and 4. Now in example 2, what ends up happening is we're going a full circle around. And since we're going a full circle around, our initial point was pi over 4, but we have to add 2 pi to it. So what that does is it gives us another point. It's got the same radius, but now it's 9 pi over 4 because I went a full circle revolution around, giving me that pi over 4. So this one went counterclockwise. Now the number 3 example is going clockwise, and so the angle that's being created is a negative angle, and they have it written down for us there as negative 7 pi over 4. But notice that we end up at the same spot. So we're still going to be walking in a forward direction, so it's still positive, and we're going to have a negative 7 pi over 4 as our angle. In this other example, we're going again counterclockwise, and the angle that's created, if you can't see it very well, it's 5 pi over 4. But now we can notice that we're facing this way in order to where the angle stops. So in order to get to the point P, we have to walk backwards. And so since we walk backwards, we need to put that negative there. And so negative 2 comma 5 pi over 4 leaves us in the same place as P. So those are 4 representations for 1 point in polar. Are we okay with that? Yeah? All right, cool. All right, now this example is negative 4 pi over a negative pi over 2. So I'm just going to draw it real quick so you guys can see how it's generated, and then I'll put it on the graph so you guys can see. So the negative pi over 2 tells us to go this way, right? And then that's telling me I'm facing going this direction. But the negative 4 tells me to go back 4 spots, right? So this right here would be, we'll call it point P again, at 4. So in our example, it would be right here. Does that make sense? Right? Now from there then, what they're asking us to do is to write this in the simplest form. So we're going to do that. So I can make up any rotations that I want, right? And so how can I end up at that point? Well, the easiest one to do would be to rotate this way and then go 4 up. So if I rotate it that way, let's call that point A that's going to end up there, right? So point A would be, that rotation would be pi over 2, right? And the radius then, because we're facing the direction that we want to go, would be a positive 4. Okay? Let me do it in another color. Another way to do it, we could do a rotation where we go around 3/4 of the circle. We'll call it point B. And now we're at 3 pi over 2. But are we going to walk forwards or backwards? What do you guys think? Yes, we're going to go backwards. And since we go backwards, this has to be a negative 4. So those are 2 examples. Now there's a ton of them that we could do, right? We could have gone well, no, I think that's it actually. Oh no, because it's 2 pi, I could have gone a full revolution, right? So there is other ways to do it. Okay. Why don't you guys, I think we did this last time. Did we do this one? I think we did, right? I think this was the last example that we did. So I'll just do it again. So in this example, then what's going to end up happening is, again, I'll draw the little example for us so we can see how it's generated. Okay, so it's saying that we're going to go a negative 5 pi over 3. So negative 5 pi over 3 is telling us to go this way. And this is the angle that we end up with, correct? With a length of 6. So this is going to be that 6 comma negative 5 pi over 3. But if we were to do coming from the positive side, that would be, again, going forward. So that would be 6 and then pi over 3. Right? And then if we wanted to do a different angle, what we could have done is we could have gone this way, which would have produced this angle right here. But then we'd have to walk backwards. So that would be a negative 6. And our angle here would have been 4 pi over 3. Oh, okay, cool. Thanks, Bon. Okay, so does that make sense? Are we okay with that? Okay, very good. So let's do number 3. And so in this example, again, I just want to draw it so you guys can have the reference. I think it's powerful to have the reference. So I'm going to go 5 pi over 4, because that gives me if I'm walking forwards or backwards. And then it tells me to go backwards 4, right? So that means I'm going to end up over here. And this point is going to be negative 4, 5 pi over 4. And so coming this way, that's going to be pi over 4, right? And we're going to go forward, so it's a positive number. Another way to do it would be to go this way. Now, if we go that way, isn't that 3 pi over 4 rotation, right? It's a negative 3 pi over 4 for the angle. And then are we going to walk forwards or backwards here? Back. And so it should be negative 4. And so those are our 2 representations of these angles. I hope that makes sense. Go ahead and try and practice this. But now we're going to get into some problems with polar and rectangular. So converting from one way to the other. I think this is actually pretty cool. So the r theta, it basically implies xy. And so what we're going to do is, if you're given, depending on what you're given, so if you're given r and theta, the way we attack this is we're going to go, okay, cosine of theta is equal to x over r, right? That's something that we learned before. It's the x over the radius. So what I'm going to do is I'm going to go r cosine of theta is equal to x. So now we know a formula that correlates x to r and theta. Okay? Now, we also know that Sine of theta is y over r. So then r sine theta is equal to y. And that's the other one that we now have. So those are to convert from polar to rectangular. And then it, ooh, that's terrible. Now, given that they give you x and y, what we can do is we need to convert it to circles. And so circles are using the r squared is equal to x squared plus y squared. And then we need to remember to find our angle. Tangent of the angle is y over x. And we can solve problems that way. Okay? That's the basic information that you need to know to do these conversions. Now let me do some examples with it so that you guys can actually benefit from it. Okay? All right, so check this out. So number 4 says, find polar coordinates of the point that has the rectangular coordinates 0, 4. So that means we're given the x and y. So we're going to have to use the r squared equals x squared theta plus tan theta, right? But let's try and see if we can do it an easy way. So let's graph it and see what happens. So if I were to graph it, oops, terrible. The point 0, 4, isn't it right there? So if that's our point, do we know what the angle is that's going to get us there? What do you guys think that angle would be? And remember, it's coming from here to here for the angle. So yes, it'd be pi over 2. So in this example, my angle is pi over 2. And what is my radius? And remember, it's from the origin. So what would the radius be? Shouldn't it be 4? Because this distance from here to here is 4, right? So that's one way to do it. The other way to do it would have been to go, okay, r squared is equal to 0 squared plus 4 squared, which would have been r squared is equal to 16. So r is equal to plus or minus 4, right? But our radius is going to be a positive in this case. Now that we have that, we could also find out the angle. And that would have been 0 over 4. So then when is tangent of theta 0? X. Ooh. I did it wrong, actually. My bad. It's 4 over 0, which is undefined. And then when x is undefined, we know it's either at pi over 2 or 3 pi over 2. And so what ends up being cool about this is our theta would have been pi over 2 or 3 pi over 2. And so really the two answers that you could potentially get, and I can do it that way if you'd like. The positive case would go with the first angle. The negative case would go with the 3 pi over 2. Does that make sense that the 3 pi over 2 would be one of the answers? Because as we go through the angle, then we have to walk backwards. Would you like me to draw that? Okay, cool. Good. Okay, so this next example, it's 2 radical 3 and a negative 2. So I'll graph that real quick just so you guys can see it again. And x is positive and y is negative. So we're going to be in the 4th quadrant. So 2 radical 3 is going to be somewhere over here. And then a negative 2 is down here, right? So we're going to get this guy. And so this is the angle that's created, okay? So I'm going to go around and that way because I'm going to try to use the positive case, okay? And there's our point. So then our x is 2 radical 3. Our y is a negative 2. And I'm going to go, okay, x squared plus y squared is equal to r squared. And so I'm going to get 2 radical 3 squared plus a negative 2 squared is equal to r squared. So that's going to be 4 times 3 is 12 plus 4 is equal to r squared. So 16 is r squared. So r is plus or minus 4. And I'm just going to use the positive one for this first answer, okay? Now, to do this then, I need to get the angle also. And the angle is going to be found by going, okay, tangent of theta is equal to y over x. So then tangent of theta is a negative 2 over 2 radical 3. So then tan of theta is a negative 1 over radical 3. Or we can think of it as tan of theta is negative radical 3 over 3. And then if you guys have your unit circle, you can find out when is our y value, negative 3 over 3. And what that ends up being is that happens at 11 pi over 6. So then our answer to this one would be 4, 11 pi over 6. Does that make sense? Yes. So you can see here, if you're given x and y, that's the two formulas that you're going to use to solve for your radius and to solve for your angle. Okay? And then the other two boxed equations are what you're going to use if you're given the r and the theta. Does that make sense? Awesome. Good, good, good. Okay. So now in this next example, we can see instead of having x and y, they're giving us r and theta. So this is r, this is theta. And now we're going to solve for x and y. So with those, the formula was x is r cosine of theta. And y was r sine of theta, correct? So to do that then, what I'm going to do is I'm going to go, okay, x is going to be equal to a negative 4 cosine of pi over 3. Now what is cosine of pi over 3? Great question. So the problem actually tells me this, and the question that was asked is, how do I know it's r theta and not xy? See how it's saying find the x coordinate to the polar? So it's telling me those are polar. In the other one, it was saying find the polar when you have the rectangular. But another way to know it, just in case, is whenever they give you they're going to ask the question like that, but whenever they give you pi over some number or things like that, they're not usually referring to a y value. It's usually an angle. Okay, but they will clarify, find the rectangular when you have the polar. Find the polar when you have the rectangular. Does that make sense, Leah? Okay, cool. Now, what is cosine of pi over 3? Those unit circles that I've given you guys should be out and being used. It should be 1/2. And so as I clean this up, my x is going to be -2. Now I got to find my y. So y is -4 sine of pi over 3. And sine of pi over 3 is what? Do you guys remember? It's radical 3 over 2. Get those unit circles out and use them. And so this is going to be the 2 and the 4 will reduce down. So I'm going to get -2 radical 3. And so my answer to this problem is going to be -2 radical 3. So that's telling me that I am in the third quadrant, right? And that should make sense if that's the third quadrant, because the angle that was produced was pi over 3, but then we needed to walk backwards, so we went this way. And that is in the third quadrant. So that's how you can check it. Does that make sense? So this is where we're actually at. Okay, cool. All right, do you guys want to try, do you want to try number 8? Or do you want me to just keep working them out and you guys can go over the notes on your own afterwards? I'm fine either way. You know what I'll do actually? I'll work it, and then when I post the recordings, you guys can try the problems and see if you can do them yourselves and then watch me do them, okay? All right, so for this problem here, they're telling us that we have this equation and they want us to turn it into polar, right? So that means they want us to find the r and the theta, right? So if we're gonna do that, it actually isn't too bad. This equation, I could already clean it up easily to go x squared plus y squared is equal to 4. And what do we know about x squared plus y squared from the equations? Isn't x squared plus y squared equal to r squared? So this part right here really is r squared. So r squared is equal to 4. So that tells me that r is 2. Okay, and that is my equation for this thing. Since we don't have an angle, it's giving us the whole circle. And the whole circle has a radius of 2. Now, do you want me to do it the long way? I could do it the long way so you guys can see it that way also. But I think this is the most effective way. Okay, let me do the next one. This is number 9. And so number 9, they're giving us this equation that is in rectangular. And they want us to get polar. So see how it's got the equation, it's saying 2 polar. So since it's saying 2 polar, that's what we need to find. Now, one of the important things is this highlighted piece right here, that is the slope, right, of our equation, because it's y is equal to mx. So what I'm going to do when I write this problem, I'm going to go y is equal to radical 3 over 3x. And then what I'm going to do is I'm going to change my y to r sine theta, keeping the radical 3 over 3 because that has nothing to do with x and y. And then r cosine theta, because r cosine theta is my x. Does that make sense to you guys? You okay? Okay, so a manipulation that I'm going to do to both sides is I'm going to divide by r here. So I'm going to divide by r here. And that's going to give me sine of theta is equal to radical 3 over 3 cosine of theta, because the r's are going to cancel out. And then what I'm going to do is I'm going to divide by cosine of theta to both sides. And that's because I want to get the radical 3 over 3 by itself. So that side will become radical 3 over 3. And then what is sine over cosine? Correct. So we get tangent theta. Now from here you could do tangent inverse of it, or you could look at your unit circle and we see that theta is pi over 6. And that is our equation. Are we okay with that? Okay. All right, so check this out. This next one's a little bit more complicated because in the previous example that we had on number 8, it was just a number 4. On number 10, you see that that third term is a 2x. So now we got to learn some crazy math. So what I'm going to do is I'm going to write it as x squared plus y squared minus 2x is equal to 0. Now what do I know about these two? What can that be? What is that equal to in polar? Perfect. That is r squared minus 2, but what's cosine? I mean, what's x? Isn't x r cosine of theta? Right? My x here is this piece right here. Right? So I've done nothing. It's still the original equation that we have. And so what I'm going to do is I'm going to factor out an r. And now I've got to solve for the equations. So it's either r is equal to 0 or r minus 2 cosine theta is equal to 0. So r is equal to 2 cosine theta, or r is equal to 0. But if r is equal to 0, do we have anything? We don't, right? So then this guy cannot be a solution, because it'd be a point at the origin, which is not what we want. Okay? All right. Now what it's asking us to do to see if we can convert. So again, look, it's saying convert each polar to rectangular. So it's saying, hey, can you go r theta and turn it into xy? Okay? And so r cosine theta, isn't r cosine theta, isn't that x? Right? So in the rectangular form, isn't that when x equals 4? So then x equals 4 would be a point here, and isn't that just a straight line, a vertical straight line going through 4? Okay, good. All right, now the next one, and I'll do it in a different color because I want you to see the difference, is it says r is equal to a -7. So if r is equal to a -7, I'm going to end up having x squared plus y squared is equal to r squared. So x squared plus y squared is equal to a -7 squared, which is going to give me x squared plus y squared is equal to 49. So that's my equation. And the center of the circle is where? It's at 0, 0. Because if just trying to recall some stuff from your algebra, intermediate algebra class, x minus h squared plus y minus k squared is equal to r squared, where h comma k is the center. Do you guys remember that? So what ends up happening here is our radius is 7. So the picture of this one is, bear with me. Isn't it that? Well, close to that. It's the circle that goes around. But do you guys follow the premise of what's happening? It's just the same thing going over and over, right? Okay. Let's go on and do 12. I'll do number 12, and then I'm going to stop us here for today, unless you guys want me to keep going. I just don't want to go give you too much information. I want you guys to be able to absorb this, and then I want to give you guys time to be able to do your quiz. Is that okay? Okay, so let me do this one example, number 12, and then we'll pick up on this on Tuesday. Cool? All right, so in this example, they're telling us that the angle is 7 pi over 4. So since we're given the angle, we need to use this here, which is equal to y over x, right? Tangent is equal to y over x. That's terrible. So then, if we have that, what is tangent of 7 pi over 4? Isn't tangent of 7 pi over 4, isn't that -1? Right? And since tangent of 7 pi over 4 is equal to -1, y over x is equal to -1. So y is equal to a negative x. So this equation is y is equal to -x. And y equal to -x is going to be that line right there. Try to make it bolder so you guys can see it. So that is y is equal to -x. I'll do my other one in a different color so you can see it. So it's saying r sine theta is equal to 6, but what do we know about r sine theta? Do we know anything about it? R sine theta equals what? Yeah, it equals y. So in our problem, y is equal to 6. So that is this equation. Y is equal to 6. And so I'm going to go 2, 4, 6. This is 6 right here. And my equation is going to be, oh, that's janky. It's going to be this horizontal line. That is y equal to 6. Do you guys see how the polar graph and the x-coordinate have some similarities? It's just that there's angles instead of, you can still have x and y, but you have angles. Oh, okay, so y equals 6 is, y equals anything is a horizontal line, right? So like if I gave you y is equal to 2, when I graph that, I'm going to go up 2, and then my line is right there, right? If I have x equals 2, that would be a vertical line that goes up at 2. It's just y equals anything is horizontal, x equals anything is vertical. Got it? Cool. So that's just understanding those angles. So I think I'll stop here. I'll stop recording right now, and then I can answer some questions for you guys if you guys need, but this is what I'll post for today. Okay?